Hello, welcome. In this short video, let us look at the distributive property of dot product. It is given three vectors A, B and C. A, B and C. We want to prove that the dot product is distributive. That is A dot B plus C should be equal to A dot B plus A dot C. For example, in electromagnetic theory, we can write the vector A as ax x hat plus b ay y hat plus az z hat, where x hat, y hat and z hat are the unit vectors and ax, ay, az are the scalar components in each direction. So this is the definition of the vector A. Similarly, we have the definitions of vector B and C in the three-dimensional space. Bx x hat plus by y hat plus bz z hat, and finally C is equal to cx x hat plus cy y hat plus cz z hat. So given these definitions, now we can write the dot products. That is A dot B plus C is equal to ax x hat plus ay y hat plus az z hat. And we want to find the dot product with this vector with the sum of B plus C, which is the sum of B plus C is Bx plus Cx into x hat plus By plus Cy into y hat plus Bz plus Cz into z hat. And the dot product of these two vectors is obviously the x hat goes with other x hat, and the dot product of x hat with y hat and x hat with z hat are 0, and only x hat with x hat is 1. So we have ax into bx plus cx. And similarly for y hats, only the dot product with other y hat is 1, and dot products with x hat and z hats are zeros. So we have ay into by plus cy. And finally we also have az into bz plus cz. Since the dot product of z hat with z hat is 1, and that is z hat dot x hat and z hat dot y hat are zeros. So we have this final product, sum of the products. Now the right hand side, the term on the right hand side, that is RHS, A dot B plus A dot C, that is the dot product of A and B plus dot product of A and C. We have ax x hat plus ay y hat plus az z hat, dot product with the vector B, that is bx x hat plus by y hat plus bz z hat, plus dot product of A with C, that is ax x hat plus ay y hat plus az z hat, dot product with the vector C, which is cx x hat cy y hat cz z hat. So this becomes the dot product of ax x hat with bx x hat is ax into bx, and the dot product of ax x hat with the other two components, that is y hat and z hats, are zeros, so we can ignore them. And similarly, we have dot product of ay with y hat, ay into y hat into by into y hat. We have ay into by, and ay into ay y hat into bx x hat is 0, and similarly ay y hat dot bz z hat is 0. So we can ignore those two terms too. And finally we also have az into bz. And in the second case we have ax into x hat dot product with cx into x hat, which is ax into cx. And similarly, as in the first term, x hat dot y hat is 0, so we can ignore this second dot product, and also ax into x hat dot cz into z hat is also 0, so we can ignore that. Cy plus az into, now rewriting this sum, we have ax into bx plus cx plus ay into by plus cy plus az into bz plus cz, which is same as the dot product of A with the vector B plus C, that is this term. Therefore the dot product is distributive or sum. A dot B plus A dot C. That is A dot B plus C is equal to A dot B plus A dot C. Thanks for watching.